Hello everyone. In the previous video, we went through the question reverse nodes in K group. We did the theory part of it. In this video, we were supposed to implement it, and that's exactly what we'll do. So let's go over to the big screen and get started. So we start off by initializing our dummy node. This will be a new list node. The value doesn't really matter, but it should point to the head of our linked list. Then we said that there will be two more variables, previous, which will point to this dummy node, and our current node, which will track the beginnings of each group in every iteration, as we will see very shortly. And that will point to the head of the linked list. And while this current node has not reached the very end of this linked list, we keep moving forward. Inside, I already explained the significance of this tail variable. I'll repeat that. It simply will be tracking the last node of the reversed linked list. So I'm just calling it tail over here. We will see where it is used very shortly. For now, let's just assign it like this. Then we have our counter, which will be 0 in every iteration. So it's reset whenever we change groups, which is what we're supposed to do anyway. Now, let's start with counting the number of elements in this current group. Do we have enough or do we not have enough? So while current has not reached the end of the linked list, and now keep in mind I'm using the and operator. Previously I mentioned or. So if you caught my mistake in the previous video, great. Otherwise I'm correcting it now and saying that it is an and operator because both have to satisfy. The second condition being that our counter should be less than k, which is when we will keep moving this current node forward and increment our counter by 1 every single time. Alright, but how will we know if our group is complete or not? I said that previously, that if our counter happens to be equal to k, well, let's start with the less than k condition. If a counter is less than k, that means the group is incomplete. Alright, that is when the previous node, which is tracking the last node of the previous group. Again, I'm just repeating what I said in the previous video just to refresh your memory. This previous node, which is basically representing the last group, that last node will start pointing to our tail. Alright, because tail in this case represents the head of the current node because it has not been reversed, right? So we are simply attaching this very group, whatever is left of it, to the previous group as it is. Otherwise, what we'll do is we will point this previous group to whatever is the output or the returned value of a function that I will just implement shortly, reverse linked list, and that will need our tail as the input because this current variable has now been moved forward. So the reference to the beginning of our current group is with this variable, and of course the number. All right, and let's assume that this function works. It reverses the linked list, returns the head of this reversed linked list. What are we supposed to do now? We are also supposed to move this previous node forward. Right? This previous node has to move to this reversed group's last node. Where will it go? It will simply become the same as this tail node, because as I mentioned, this tail node will be the last node of this reversed linked list. All right. So that is what we have. Lastly, after we're out of this while loop, all the elements have been processed, we will return the node that comes after our dummy node. But there's one thing left here, that is to reverse the actual linked list. That is what the question requires of us. So I will start off with a function, give it the head of the current group and the value k. All right. To reverse this, we will use a while loop and write down the conditions that our current group head should not be equal to null, and the counter, which will be set at 0 at first, should be less than k. So a very similar condition to what we saw over here. All right. But that was just to count the number of elements in our group. This time we'll actually reverse it, which will be written inside this loop. But before that, let's just initialize a couple more variables. So this previous variable can be considered as null, which will track the previous node than the one we'll be processing in that very iteration. The current node will track the node that we are supposed to reverse at that very moment in the process, which will start with the, of course, the head, this current group's head, and then we can return some value which we'll see in a bit. So here what we're supposed to do is get the next node first. So the next node, as you would guess easily, is the one that comes after current. Now we have the reference to the next node, we can safely point our current node to the previous node, because we have to reverse the list, right? So we have to go in the opposite direction. So this current node can start pointing to the previous node. What will happen next is that for the next iteration, we have to set the variables now. So previous will become current, and current will become the next node. Alright, so we basically said that in the next iteration, when we see this, go through this while loop once again, go to the next element, what we're supposed to do is treat the element that we're treating now as the previous node, and whatever comes next will be treated as the current node, right? So we move forward one by one. And lastly, we'll have to get a counter which will increment by 1, so that we know when to stop reversing the nodes in this particular group, because we're not actually sending just, let's say, these two nodes in this group. We're sending the entire list, right? So we need a stopping point. That stopping point is determined by this counter. Once that is done, what will end up happening is that the list will be reversed and we have to return the head of this new list. So that will be found over here, previous dot next. Not previous dot next, just the previous node. So let's just try to dry run this just to give you a general idea so that you understand what's going on. I will use a very small linked list. 1, 2, 3. So we have our previous pointing to null. Previous is at null right now. Current, which is C, is at 1, and counter is at 0. While this current node has not reached the end of this linked list, or let's say the end of our number that we're supposed to process, the number of elements that we're supposed to process, what we'll do is written over here. We'll get the next node, which is after current. So the next node right now is 2, right? We say that current's next node can become previous. So current will start pointing to previous, which is null, which means this connection will now break. Then previous will become current. Previous will become current, which is 1. So previous can be updated over here to 1. Current will become the next node, which is 2. and counter will increment by 1. Alright, so we'll repeat the process. We have our current node as 2, next node will become 3, current's next node will become the previous node. So current, which is 2, its next node will become the previous node. Now you can see the linked list actually reversing, right? That is what we're doing over here. So this connection will now break. Then counter will increment by 2, and of course previous will become the current element, which is 2. So that current element can become the next element, which is 3. We'll repeat the process. That will just move this arrow over here instead of over here, and we will return at the end of it the value that is 3. At the end of every iteration, you notice that previous is the one that is coming out to be at the end. So let's just do this iteration just to give you complete closure on data. Current item is 3. We will start pointing it towards 2 after having the next node over here, which is null, right? So that's null. This will start pointing over here. Previous will become 3, current will become null. 3 is what we have in this previous variable, which is also the head of this reverse linked list. So that is what we will return. All right. So we have the complete solution over here. I don't think I'm missing anything else. So let's just try to run this. Okay, some variable is missing. Oh, I missed an R, a spelling error to start off. And okay, this will also be, okay, I think we're good. Although what I should have done is used current. The basic case has passed, but that will not pass all the cases. All right, let's try to submit this. And it's passed. It's a pretty good solution. And you can try another approach here, which uses recursion probably, but that will take up some extra space. This one does not take more than constant space because we're following an iterative process. And even here, we're not making any recursive calls. So this is a pretty good solution and you can use that in your interviews. And in the next video, we'll solve another one. So stay tuned and follow for more.